the next presentation is Sam Bray, who is doing a Bachelor of Science in Computer Science. Oh, that's right, he's a graduate now. When he started, he wasn't. Now he is. Time changes so fast around this place, you can't stand still for any moment at all. So he's been working on a multiplayer environment for studying health-related behaviour. He is being supervised by Stephanie Thomas, who is in Norway at the moment. And during the demonstrations, she should be watching us at the moment. It's, I think, 7 a.m. in Norway, but that should be early enough. And for her to be able to join us. And during the demonstration session, actually, I think during the demonstration session, she will actually take place in part of the demonstrations.
The will, there's a way.
That's right. Yeah. So we have electrons going over the internet to do all those communications for us. Stephanie's from the Faculty of Business and Law, so over to you, Sam.
Cool, thank you very much. Good afternoon, everyone. So as I said, I am Sam Bray, and I had the wonderful privilege of working on the multiplayer virtual reality HIVE project, looking into studying health-related behavior. So our project team was the wonderful and incredibly enthusiastic Stephanie Thomas, who, as I said, was working with business and law. She has a focus in experimental economics as well as health economics. The humorous and wise Wesley Lamont was a wonderful guidance from the HIVE as well, with great Unity and visualization experience and expertise. And me, the intern, who's having a good time, a computing graduate with a love of graphic and game design. So this has been absolutely wonderful for me. So thank you very much for everyone. So, the background around our project. So our project is looking into the area of health economics, specifically the interaction between health and group decision making. So in this case, health we're referring to potentially the impairments, be it physical or mental, of certain members of those groups. So in this case, looking at groups with members being impaired, how does that group cooperate with that impaired person? How does individuals in that group, do they sometimes become more selfish? Do they not want to interact with them? Do they actually sometimes become more charitable and want to give to that impaired player? This is basically we're going to be making an environment for future studies to actually test these kind of things out. But so these, in general, in these studies revolve around putting one of these groups into a task and watching how that group dynamic works within that task. Working with these groups and performing a task, there's two real options. Either you gather a whole bunch of people together in the real world and put them into a simulated kind of artificial lab scenario and get them to agree on a set of rules and have everyone partake in this kind of game. The other option you really have is putting everyone into a virtual scenario, whereas instead of having everyone be face-to-face with each other, potentially having them set up on computers and control virtual avatars, and then looking at the data that comes out of those virtual interactions to determine what intentions the original players had, and still building that group idea, but in a virtual sense. So, when looking at impairments with there's a few ramifications for which environment you end up choosing. So, if you want to choose a physical environment where you have people face-to-face and you want to look at impairment, the real ways you can kind of go about doing that is potentially using special equipment to impair a person in the real world. This can introduce a few uncontrollable side effects. For example, an example of trying to impair someone in the real world with some special equipment would be saying taping their hands together so they can't grab as easily anymore. That can work well, stopping someone from grabbing, but one of the problems with that is that might be very, very uncomfortable, thus making that participant very irritable, thus making that person not want to cooperate with the rest of the group because they're just very angry, which isn't really the whole point of our study. We've kind of now gotten around that and everything's gone a little bit wrong. One of the other ones is just, say, putting restrictions on someone, saying, no, you're not allowed to jump. And then halfway through the study, you see them hopping around going, wait, no, none of that as well. It's all just basically word of mouth agreements and stuff like that. It's not highly controllable, which is what we really, really want to look at. So we're going to look at virtual environments where we can have complete control over everything. One of the abstract game mechanics, which instead of saying no jumping, we can literally just say, look, your control, normally you press A to jump. I'm going to disable that. You are literally no longer able to do that thing that I don't want you to do. There's no agreement there that is just completely controlled. The one which is going to be particularly interesting for us, though, is virtual reality. So because you're affecting a virtual body, you can simulate much more realistic impairments, just like the original ones, but no longer, this isn't going to have any special equipment which can be uncomfortable and stuff like that. One of the other benefits of using virtual reality for impairment as well is that not the player who is inhabiting that virtual body doesn't feel like they're just puppeteering a separate impaired avatar. They are inhabiting that avatar. They feel that they are impaired. And as well, in these group scenarios in virtual reality, there's a large sense of presence between group members as well, and you feel that the person next to you, you feel that they are impaired. They're not just some virtual avatar that can't jump, that kind of idea. So virtual reality is the one that we're particularly looking for, and we found particularly interesting for this kind of study. So our project. So develop a virtual environment to be used in future studies into health economics, with the requirements of this being that this virtual environment is going to have to be multiplayer, because we're looking at group dynamics. So we're going to have to make sure that all the virtual people play nicely with each other. Virtual reality, so making sure that we have that up and running so we can run those realistic virtual impairments, as well as there's going to need to be a group cooperative task in this environment, because you need to have one of those tasks to be able to observe how that group dynamic switches and changes. So looking over that task, the task being the main kind of core observable component of this project. So the task could be one of many things, any suitable task. So what we've decided to do is, instead of going and trying to find a task and build around that, instead identify task requirements that we require and then build a task to suit our needs. So the task requirements we found that we probably do need is that the task could be performed on your own or cooperatively. The reason for this is we want a task that has a large dynamic range of cooperation to allow the group dynamic to change and have a large amount of contrast. So if someone doesn't want to cooperate, they don't feel like they have to. And the other one is to also have a variable number of participants be able to perform this task. So because we're going to be building this for future studies, we don't want to limit people to say, you must have 4 people, you must have 20. Basically build it so that it can run for 2, it can run for 4, it can run for 8, any kind of number. The third one was making sure that it has room to be able to have its participants be able to be impaired. That's what this is all about. And the fourth one, which is more of a preference, that we're talking to my supervisor, is have this task allow for adaptation and introduction of new elements to be able to make this extensible in future. There'll be an example of that later on in the project. But so the task that we ended up creating and settling on was round block cluster assembly, which is more of a description than a name. We can think of a name later on for that. But the main concept around this task is that each player has a color and can create blocks of their own color that others cannot. This is their supply. They can share and trade with other players, and the goal is to combine these blocks into clusters of size equal to the number of players. So if there's 4 players, you're going to make a cluster of 4 blocks. So as the red player, I could work on my own, just make 4 red blocks, put them together, have a block of size 4, and then score that for points. Or, if I decide to, I could work with the yellow player and build a cluster with some red blocks and some yellow blocks. And the whole point of this is that the idea is to achieve the maximum number of points per cluster is that you need 1 color for every single player in your cluster. And that basically is our incentive to get people to collaborate if they want to. And that is basically the demand in this kind of idea as well. So in regards to those task requirements that we just brought up, this can be performed on your own or largely cooperatively. It can scale up to any number of players, any number of colors, number of players. It basically just, whatever size players you have is just how many blocks you need per cluster. And it's also fairly bare bones basic. It can have elements introduced into it. Also the scoring mechanic can be largely changed. All we really decided is that we have a minimum points and a maximum points. You can have a lot of variations on top of that. For example, everyone who put in gets points split across all of them, or what the person who scores it gets all the points. Lots of different variations for whatever studies need to be done. And the impairment we're looking at in this one is going to be regarding how people actually combined blocks into these clusters. So, button press. There we go. The way in virtual reality we're going to have these players combine blocks is going to be basically they go into a spawning block, they spawn 1 block in, spawn a second block, and then hold them together for a certain amount of time. Now, that is the amount of time that we can control and say, cool, it takes this long for an unimpaired player, and it takes this long for an impaired player. And mathematically, one player is impaired compared to the other ones. What we're also looking at this is still somewhat simulating an impairment of loss of hand dexterity or hand functionality. So with this, what we're doing is so instead increasing the time taken to merge, as well as introducing a visual, so to let the player know and others know that their hands have become impaired. In this case, we're applying a hand tremble, which is a common sign of loss of hand dexterity or hand functionality. So, so with all that said, here is everything put together in Unity as a working environment. So this is a 4-player setup. You can see there are 4 players around the place. Those pipes are the sending and receiving pipes, which players can use to trade around, or they can physically pass things or even throw blocks across the room and have other people catch them. This is also just the perspective from the yellow player who's currently just merging 2 blocks. One of the task variations, which I mentioned before, is an example of how this environment can be adapted for different studies, is introducing a basically wall in between everyone. So this removes the ability to see other players, which can be an interesting thing for a different study who's looking at specifically how people feel towards the impaired players. So normally if you see someone who is struggling and is shaking hands, trying their best to merge 2 blocks together, and you're waiting for them to send you something, you go, oh, okay, they're trying their best. But if you remove that, are they just being lazy? Are they just trying to cheat you out of giving you a block back? Who knows? So yes, so this task has a lot of room for improvement, or it's more like extension to allow different studies to look at different things. So let's jump over to the next one. The Unity build has also been built with scalability at its core. So fun thing, everything on here has basically been placed there by the computer. I did not hand place a single thing in that. Whereas with most environments, it's built by a designer because we want this to be able to fit 2 players, 3 players, 8 players. Everything is basically procedurally placed into the world, as well as a large number of the shapes in that are actually procedurally generated through code. That was a lot of programming. And you can see it gets a little bit crazy with 8 players, but you can do it. One of the other limiting factors we actually have chosen at this point is we have chosen to currently use a color palette which is available to be used by people of most visual capabilities. This color palette currently should be able to, I think, handle most color blindness, but basically the only limit is the number of colors you have, and we chose to limit ourselves to 8. So it can potentially go up to 1,000 and it should still work. It would just be insane. Moving on, so one of actually the parts of this which was the main core difficult part was this was all crazy building everything in code. However, the part of this which is a little bit crazy, which you're talking about multiplayer with Mark, these people aren't actually in the same world. They look like they're in the same world, but that's not really how multiplayer actually works. So, the common concept with multiplayer is that everyone basically joins, they put their virtual avatar into a single virtual world, and they all exist there. Now that does work if you're running on one computer and everyone kind of has all their controllers or headsets plugged into one computer. Everyone exists on that computer. That works. But specifically, especially with virtual realities, often you need multiple different computers set up, often with multiple different rooms, because virtual reality can take quite a bit of space. So because that's running on multiple computers, they're each running their own version of the world. No one's actually in the same thing. Everything's just synchronized very nicely to make it look like there's one world, which was the real crazy bit of this project. So going into that just a little bit is some of the difficulties with that. So with this kind of idea of there's multiple worlds running around, but we want to make it look like there's one, you have the large problem of synchronizing everything. Say if you had a clock in each of those worlds and let the clock just run as fast as it could on those computers. One of those computers, say, is pretty old, clock's running decently slow. One of the other computers is super fast, super awesome, costs millions of dollars, runs amazingly quickly. So those times aren't going to be exactly the same. But you want to be mimicking, though, that you're all in this single environment. The world is just one thing. So you're going to have to, at some point, work out who's right, who's wrong, but who to say, really. You can just arbitrarily pick one player and go, yep, nope, they're right. They get to control everything. They're the master in this case. But that will give them an unfair advantage over everyone else. They'll see everything calculated locally, whereas everyone else will see everything lagged behind the network latency to when they say what is correct. So the way to really mostly overcome this is to basically have a impartial observer outside of everything else, basically called a master server, which basically says, cool, look, I'm none of the players. I just get to be an adjudicator and get to say, cool, this is what I think is right. This is what I'm going to tell all of you is correct. So they get to act as an impartial, basically adjudicator and solve all those disputes. But the one problem with this setup is it does solve that problem, but another problem that arises is the fact that now all kind of these ground truths in the end are now sent over the network, which can be good, but it solves all the synchronizing problems, but in virtual reality, often comfort is a big issue. So one problem that can pop up with that is, so as you saw before, you get to pick up blocks and move them around. So blocks and where they are is synchronized across the network because you want to make sure that everything looks like it's one world. But if I pick up a block and move my hand over here, if I'm waiting for this thing to tell me where that block is, I move my hand over here, I send the fact that I moved to the master server. Master server works out where the block goes. Master server says, oh, okay, cool, the block should be over here. And meanwhile, I'm waiting here this entire time, waiting probably a few seconds for it to then ping back and go, oh, that felt really weird. And if you're moving your hand around a lot, that block is going to be lagging behind you massively, and it feels really, really disconcerting. So one crazy thing you can kind of do is, rather than just having one single master server take care of everything, you can actually have control be passed around per synchronized component. So as soon as I grab that block, I can actually say to everyone else on the network, I control this now. This is not the master server's anymore, this is mine. So I get to move it wherever I want, and then I send over the network where that is. So that the local player who is actually interacting with it feels no discomfort and it has complete responsiveness with their interactable world. And everything else, they get to see the network latency version of that afterwards. The other benefit, however, of having that master server is that you can also have one spot to take care of all other clients and tell them all the information they need to know. So instead of having to necessarily rebuild or change the actual Unity code every single time you want to have a slight variation to this environment, if you have that one client who gets to tell everyone else what's happening, you can actually have that set up at the start and have multiple variables be able to set up. So basically it also allows you to have a menu of setting up this environment before things go crazy and start running, and you don't have to go rebuild everything every time and have multiple different builds for this slight variation, this slight variation. It also lets you just have one spot, which you can set up all the different variables you want for your scenario, control all the different player settings, and then send those out to all the other players when the game starts, which is another great benefit of that. But with that, there's still a lot of future work to probably be done on this. There's definitely more features which can be introduced with the extensibility. Money trading or point trading is one of the big points that we're interested in as well. So rather than just trading around the blocks, which can be scored for points, actually trading around those points directly and viewing that more as sometimes more of an insurance idea can also be done there. Potentially allowing stealing. What will happen with stealing and impaired players? Will people steal from the weak, or will they steal from the rich and give to the poor, Robin Hood style? What happens if all the scores are publicly available? Will people then be more inclined to help people who are impaired? Who knows? And also, again, always experimenting with different means of impairment. Currently, we just have a trembling hand. However, potentially you could remove an arm of a VR player. That's something which you can do. One other point is also adding some more visual polish in there. As you probably noticed, it's a pretty bare bones basic environment currently right now, because we're mainly focusing on functionality versus how it looks. So we can definitely make the environment more immersive. And definitely introduce more high quality assets. And of course, with any large computing project, always more debugging. There's always going to be bugs in there. I did my best, but there's going to be bugs somewhere. That's how these things work, especially with synchronization. That stuff's crazy. But there's a lot of cool and new places where this can be taken and be adapted for new research projects. But with that, thank you very much to everyone at the Hive. Thank you for Stephanie Thomas, who hopefully is in Oslo right now and is watching. And especially, I think, yeah, everyone at the Hive, thank you very much for running stuff like this. Especially Andrew. The fun thing was Andrew let me Vive headset, or actually an Oculus Dev Kit 1 many, many years ago, and somewhat set me on this path. So, thanks.